All right, and so our next unit is going to focus on circles, and today's lesson is going to specifically focus on standard 19.1. I can identify and solve problems involving parts of a circle, involving lines and segments, and then we're going to talk a little bit about circumference today as well. So for this lesson, there's not an opener because there's just so much vocabulary involved. We're going to use the opener time as our video just to go through all the vocabulary. So there may be times where you need to pause the video to write down what I'm writing, but it's going to be essential that you know all these terms. All right, so let's just go down and start looking at some of these terms. So circle, all right, circle is the set of points equidistant from a given point. And this given point is the center of the circle. All right, so the set of points equidistant from a given point. So that would be all of these points, all right, along the edge of the circle are all the same distance from our center A here. All right, now, like I was saying, if I am going too fast for you, pause the video, write the words down, turn it back on. Okay, now center, all right, that we really want to know here is that we usually label, all right, with one, all right, capital letter. All right, a lot of times it's O, circle O, okay? But in this case, we would say circle A. All right, diameter, right? A diameter is a segment, okay? So that means it has a beginning and an end, right? A segment with its endpoints on the circle that contains the center. All right, so a diameter is a segment with its endpoints on the circle that contains the center. So, all right, if I go just draw this in right here, all right, so we'll say this is B, we'll say this is C. So we would have diameter, all right, CB, okay? So diameter CB. So one endpoint's on the circle, the other endpoint's on the circle, and it has to go through the center, okay? The radius, all right, is a segment with one endpoint on the circle and the other endpoint is the center. All right, so a segment with an endpoint on the circle and the other endpoint is the center. All right, so AB would be a radius, AC would be a radius, right? If I went up here to here, AD would be a radius. So radius, all right, center to the endpoint, okay? All right, now, here's what you should know. All right, if I look at diameter DB, there takes two radii to make up that diameter, right? So the radius is always going to be 1/2 of the diameter. That's another little piece of information there. So the radius is always half of the diameter. Okay, now a chord. A chord is a segment, and I'll put AD here, all right, just so you have an example there. A chord is a segment with its endpoints on the circle. Okay, now notice it does not have to go through the center. All right, now, so CB would be a chord as well as a diameter. All right, so all diameters are chords, but not all chords are diameters. So for example, I could draw this guy right here. So let's go CD. So you can see that we have segment CD. Both of the endpoints are on the circle, but it does not contain the center. So this is just a chord, okay? So if its endpoints are on the circle, it's a chord. If its endpoints on the circle and it goes through the center, then it is also a diameter. Okay, now for the last three here, all right? So when we look at tangent, now tangent is a line. So the tangent is a line, all right, that intersects the circle in one point and one point only. All right, a line that intersects the circle, all right, in exactly one point. Okay, so we'll call that B right there. Okay, all right, and I'll just put another point out here and we'll call that C. So line CB, all right, you notice the notation here, right? This is a line, so going back to like way back beginning of the year, line CB, right, versus segment CD. So make sure you have the appropriate notation. All right, so the tangent is a line. Okay, now a secant, all right, is a line that intersects the circle in 2 points. All right. All right, so CD like that. All right, so that would be all right, that would be our secant. All right. Now a central angle is an angle formed, all right, by 2 radii of a circle. All right, so if I just do this, all right, let's call this X and Y, right? So angle XAY is a central angle, all right? And it's called a central angle. Sorry about having my paper sideways there for you, all right? Because we're at the center, all right? So one ray is a radius. The second ray is also a radius, okay? So that would give us a central angle. Okay, now there's one specific thing to know, all right, that happens when we talk about the intersection of a radius and a tangent. So if I have a radius here, we'll just say this is AB here, okay, and we have a tangent, all right, we'll say line L is tangent, all right. So whenever a line segment and a radii meet, right, this is called the point of tangency, all right, you will always get a right angle, okay, forms a right angle. And we will use that to solve problems. We just talked about the Pythagorean theorem in our last unit, right? So that will come up a lot with some of the solving that we're going to do for this particular unit. All right, so there's a lot of terminology there. All right, so once again, take some time. I would read this, every night. All right, if you read it once or twice a night, by the time we get to the test, you'll have these things memorized. Okay, so let's flip the page here and let's talk about circumference. Okay, so now, last term here. All right, so circumference is the distance, and I'm going to put as a length here, around the circle. Okay, so basically how far would you walk, right, if you went around the circle here? Okay, now there's 2 ways to think of the circumference, all right? So one way is we can say circumference is equal to pi d, and d is the diameter. Okay, now sometimes you don't have the diameter, sometimes you have the radius, and it takes 2 radii to create, all right, the diameter. So now we just have 2 pi r. So depending on the information you have, if I have the diameter, it's just pi times the diameter. If I have the radius, it's 2 radius make that diameter, and then times pi. Okay, so now, all right, let's just go through some problems like working with, all right, some of the language here. So identify a chord, all right? So use figure 1, identify a chord. Now, once again, a chord, right, is a segment with 2 endpoints on, all right, the circle. So for example, I could use LE here. So LE could be a chord, all right? All right, I also have, all right, EN here, all right? So, or EN. Now I'm going to give you multiple ones here, all right? You only had to identify one. Or we also have JE here, all right? And JE, all right, is a chord. Now, JE also is, if we look at number 2, a diameter, because it is endpoints on the circle and it contains the center of our circle. So JE is the only diameter drawn, all right, in figure 1 here. Now, identify a radius. Radius is center to the circle, center to the edge of the circle. And you can see we have several of those, right? Like AJ, AN, AE. All right, so any of those, all right, that are drawn there would work. So I'll just put AJ. All right, so identify a tangent. So remember, a tangent, all right, is a line that intersects our circle once. All right, and there's only one of those, and that would be this line out here on the side, which is LS. Now, once again, you got to be good about your, all right, notation. Line LS is our tangent. Secant is a line, right? So that would be EN here on the right side that intersects twice. All right, central angle. An angle formed with 2 radii of a circle, and there's a few different ones here. All right, so JAN would be a central angle. NAE would be a central angle. Even JAE, right? Because that's a all right, straight angle, right? We talked about in the very beginning of the year, right? So we have lots of choices. I'm going to go with angle JAN. All right, so there's some of the terminology. Okay. All right, now let's go down and look at some of the problems where we're going to use, all right, what we know. All right, so now going into, all right, looking at problem 7, 8, 9 here. So we're going to use some of the facts that we know combined with the Pythagorean theorem to do some solving. So notice I want to know this length right here, which is x. All right, but I don't have a full triangle over here. All right, I know this is 8.7. I know the radius here, and I know this is radius, it goes from the center to the edge, is 16.4. So notice what I can do. I know all radii in a circle are equal, so I can draw this in, and now that's 16.4. And now, if this is a right angle, this is also a right angle. And so now, all right, I have set up the Pythagorean theorem because now, right, I know 16.4 has to be the hypotenuse because it's across from the right angle. All right, so I know I have x squared plus 8.7 squared equals 16.4 squared. All right, and then now we can just go right into, all right, solving here. So 8.7 squared is that. So x squared plus 75.69 equals 16.4 squared, which is 268.96. All right, okay, and then that means x squared has to be, if I subtract that from both sides, all right, 75.69 is equal to 193.27. And then now I just have to take the square root of both sides here. So second square root of my answer there. All right, and I get that x is about, all right, 13.9. All right, so there's our, all right, how we're going to use the Pythagorean theorem, all right, when we're solving. Okay, now if you look at number 8, now once again you have to kind of maybe piece some things together. All right, so when I look at number 8, I want to know x, which is just this piece, which is part of the radii, right? It's not necessarily half, right? So don't make that assumption. There's nothing that tells us it's in the middle, right? But it's definitely a piece. But if I know this part, which is y, okay, if I know that part, then I can subtract it from the radius, right? So x would equal to the radius minus y, okay? So now I need to solve for the radius. Well, if I look here, this entire diameter is 33.6, all right? So now if I divide that by 2, all right, that's going to tell me what the radius is. That's 16.8, which happens to also be the hypotenuse in that triangle right there. So x equals to 16.8 minus y. Now, once again, now I have to solve for y. And then once again, I'm now in this right triangle. All right, so I can talk about the Pythagorean theorem here, right? So I get y squared plus 14.6 squared equals 16.8 squared. And then once again, we can just go through that process, right? 14.6 squared, all right? So y squared, okay, plus 213.16 equals 16.8 squared, and that's 282.24. All right, that means y squared equals, all right, and so once again, you just got to just go through the process here. I hit the wrong key, so let me try that one more time. Minus 213.16. All right, 69.08. Take the square root of all of that. And it tells me that y is about 8.3. All right, so now, right, we already knew what the radius was. So now I can do that 8.3 right there. And that tells me that it's about 8.5. All right, now, okay, notice on number 9, we have a diameter. And we have this tangent out here, which is 9. This tangent intersects my radius or diameter here, and that tells me that I get a right angle. All right, and that recognition then lets us then do the Pythagorean theorem, right? There's my C, right? So knowing that piece is really what gets us to the problem there. So then it's just 12 squared plus 9 squared equals x squared. All right, so 12 squared plus 9 squared is 225 is equal to x squared, and then I can take the square root of both sides, and that tells me that that length has to be 15. All right, so just one more problem, or two more problems here. So let's go to the page and let's talk about circumference. All right, and if we go back to our formulas, right, okay, so circumference, all right, we said was either pi d or 2 pi r, depending on my problem. All right, and notice it tells me to leave my answers in terms of pi. All right, so if I can get an exact answer, I want to do that. So notice I'm given the radius. So I'm going to want to use 2 pi r. So C equals to 2 pi r. I know r is 5. So that's just 2 pi and then 5. And then notice this is all multiplication. So then 2 times 5 is 10. So this means my answer is just 10 pi. And if pi is about 3.14, so 10 times 3 point something is a little bit more than 30. But this is an exact answer. So we leave pi as an exact answer like we have root 3 or root 4 or root 5, something like that. All right, number 11 here. So once again, now notice I want to find the circumference, but this time I have the diameter. So I'm going to use this formula. All right, so circumference equals pi d. And this time I just plug in the 12, and that's just 12 pi, and I'm finished. That's it, no more work. Exact answers are nice. That's it. All right, and that wraps up our first lesson on circles. So if you have any questions about anything, make sure you highlight those, bring those to class, and we will see you then.